Welcome back. This is the first lesson of week 7 and we're going to do more work with logic circuits and expressions. In this lesson we'll extend the range of circuits and expressions to include examples with OR and XOR. So in this lesson we'll work an example of making an expression from a circuit and then of making a circuit from an expression, and we'll look at creating truth tables with more than 2 input values. So first let's see how we can make an expression that matches a given logic circuit. So here's the first of many examples we're going to look at this week. We're going to create a logical expression, a Boolean expression that matches this circuit. I don't think you'll be surprised at the first step. We're going to label all the outputs and inputs of the diagram. So there we are. There were only 2. Right, now the way that I do it is to start at the end. So start with the final expression. In this instance, it's Q, and we write Q as the output of a gate. So Q is the output of an OR gate, and the inputs to the OR gate are X and Y. So Q is equal to X or Y. Now we work backwards from there. So if Q is X or Y, what is X? X is the output of an AND gate, and the input to the AND gate are A and B. So we can replace X with A and B, and it still has the same truth value. So Q is A and B or Y. So I expect you can see what I'm going to do next. So I expect you can anticipate what I'm going to do next. Y is the output of a NOT gate, and the input to the NOT gate is B. This is something you haven't seen before, by the way. The B wire is split, so B goes into 2 different gates. That's fine. You just count it as the same as B. So Y becomes NOT B. And that's the completed expression. So this logic circuit is equivalent to A and B or not B. So let's recap the method that we've just used. Label all the inputs and outputs with letters. This is just for convenience. Write the final gate as a Boolean expression, and then replace each letter in that expression with the gate it comes from, and keep working back like this. So every letter gets replaced by the gate that it comes from and the inputs to that gate. And eventually your expression will only include the input values, in this case A and B, and at that point you've finished the task. This was a small one. Over the next few lessons we'll look at some more complicated ones, but the method won't change. That will always be the method. And now we'll make a circuit out of an expression, and it's basically doing the same thing but in the other way round. To do this properly, you have to remember Boolean precedence. Remember not and or, and in front of that comes brackets, and after that comes right to left. So we're going to build the circuit up in order of precedence. So let's imagine that you've got to change this expression into a circuit, into a logic circuit, or you might be shown it using Boolean symbols. You really should be comfortable about swapping between either, because they could use either in the exam. Okay, so remember precedence. So which part of this expression, I've written it both ways, it's the same expression, which part of this expression has precedence? It's the brackets, isn't it? So the brackets say A or B. So the first thing that we're going to do as we start to draw the circuit is to draw A or B. So if you want to try and keep ahead of me, get pen, pencil, and just write that, A or B, as a circuit. well, a one gate circuit at the moment. There it is. You should have written that. That's A or B. So that's how we know our circuit begins. Right, so the remaining part is AND not C, which is two operators right next to each other. So which do we do first? We have to complete the gates by complete the circuit by putting these two gates in the right order. Which one comes first? It's the NOT gate, isn't it? Notice that the NOT gate and the brackets are not directly joined together. There's an AND in between them. So I'm not joining them together. I'm putting them one above the other. I'm going to join them afterwards. So not C. So not comes before AND. So I'm going to do not C. Because the not C isn't joined to the A or B, I just put them one above the other. You could have put it the other way up. And then finally, I'm joining them with the AND gate. So that is the finished task. I can now make a truth table from the circuit. Remember the method, I've added two letters to represent the intervening states. So now I'm going to create a truth table to match that circuit. Notice that there are three inputs to the circuit, A, B and C. So I've got to create a truth table with a column for each of those. Up to now we've only looked at truth tables with two inputs, A and B. And there are four possible combinations of A and B, equivalent to the binary numbers 0, 1, 2 and 3. If we add a third input, C, that gives us 8 possible combinations. It doubles the number of combinations, and they're equivalent to counting from 0 to 7 in binary. So let's see that. So if you read across, those are the binary numbers 0, 1, 2, 3, 4, 5, 6, 7. You don't have to put it in that order, in the sense that the table wouldn't be false if you put them in some other order. But that is definitely the right way to do it, because it makes sure that you've written all the possible combinations. Right, so now we've got to think what expression is equivalent to each of the letters. So D is A or B, E is not C, X is D and E, and here are all the values. So have a look down. There are three combinations of inputs that will produce an output from this circuit. So I hope you managed to keep ahead of me on that, but don't worry if you didn't, because there's going to be loads more exercises. So in this lesson, you've made an expression from a circuit and made a circuit from an expression. And we've also looked at three input truth tables and how we fill in all the possible combinations there. So I'm going to give you a couple of exercises to do, and we'll look at the answers in class. Create an expression that matches this circuit. Oh, I just wanted to say the OR gate doesn't look quite the way I usually draw them. It's got a round front. You can tell it's OR because it's got a round back. So some people draw ORs like this. And here's an expression. Write it using Boolean symbols. Draw a circuit and create the truth table.